All right, ladies and gentlemen, now that we know how to add and subtract polynomials, we're going to talk today about multiplying polynomials. And I'm going to show you two different methods to do this, and then you get to choose which method works best for you. So we're working on the same skills as last time. We're talking about interpreting our expressions and understanding that polynomials are analogous to integers. So I can do the same sort of operations with my polynomial expressions as I can do when I have just numbers. Our two vocab terms today are the two different methods that we're going to use for multiplying polynomials. The first method is the area model, and so this is a model that you may have used back in elementary school to multiply 2-digit and 3-digit numbers. What we're doing is we're splitting our things into components to calculate the partial products of each. The other method, and this is the way that I was taught algebra way back when, is using an application of the distributive property, or using the FOIL method to determine what I get when I multiply polynomials. So in this lesson today, I'm going to show you how to do both methods. And I'm going to tell you, I like the area model. I think it's the most useful way to show multiplying polynomials, but it'll be up to you to figure out what way works best for you. So first, when we practice with the area model here, we're going to go back to about 4th grade, maybe 3rd grade, and we're going to multiply some 2-digit numbers. I see 17 times 73. So what I'm going to do is I know that 17 is really 10 plus 7. I can multiply by 10s in my head, and I can multiply by 7s in my head because I know my multiplication facts. A lot easier than trying to memorize this table for 17s. And I can do the same thing with 73. Multiplying by 70 and multiplying by 3 are much easier than trying to multiply by 73. So what I'm going to do is I'm going to represent these two different expressions now that I've broken them up into their components. What do we call that in elementary school? I decomposed my numbers. Now I'm going to build it into the area model. So I'm going to take my first expression, that 10 plus 7, and I'm going to write it in a line across. And I'm going to take my second expression here, 70 plus 3. So I've decomposed it into its two components. Now what I'm going to do is I'm going to build my chart. So I'm going to take any addition signs and I'm going to extend them. So when I do that, I'll just make a nice box here now. I see that I've decomposed into 4 separate partial areas. I have the area of that first box, and then the area of each box after that will give me the total area of this expression. So to do that, now I can fill in the boxes. The area of this first box is length times width. So 10 times 70 gives me 700. The area of my next box here has a length of 7 and a width of 70. So that has an area of 490. The box on the bottom left has a width of 10 and a length of 3. So I know that it has an area of 30. And the last box, 7 times 3, 21. I can talk about decomposing it into each of these boxes here. Well, now to get my final answer, I just need to put it all back together. I have 700 plus 490 plus 30 plus 21. I can add up each of my pieces of the area to get my total area. And when I do that, I find out that the area of this total rectangle is 1,241. And I can get that by adding up each of those pieces. Because we are in the 8th grade and we use our mathematical tools, I could just type in 17 times 73 on a calculator and I'd get this answer here. But I was showing you where this method comes from because now we're going to apply it to this new situation. We're going to use it to find the product of x plus 3 multiplied by 2x plus 1. So just like before, I'm going to rewrite it. I'm going to take that first term or first expression and I'm going to write it vertically, horizontally. And I'm going to take the second expression and I'm going to write it vertically, 2x plus 1. Like before, I'll extend those addition symbols to make my chart. And what I see here now is I have those same 4 boxes. And so I'm going to find the area of each box and then I'll put them all together to find my final product. Well, the first box, when I take 2x times x, I get 2x squared. For the next box on the top right, I have 2x times 3, which gives me 6x. Bottom left is x times 1, which gives me x. And bottom right is 3 times 1, which gives me 3. Like before, now I need to add up each piece. And I want to keep this in standard form, so I want to order my different terms from highest exponent power to the lowest exponent power. So first I see 2x squared. I'm going to cross it off as I use it up so that I don't forget to copy down anything out of my box. Next box, I see 6x, cross it off once I've used it up, plus x plus 3. Well, at this point here, now I need to find my final answer, and I see that I have like terms. This 6x and x I can put together because they have the same variable raised to the same power. So in this case, my final answer, there's nothing I can put together with my 2x squared, so it stays the same, plus 7x plus 3. My final answer has each of those terms in it, and there's nothing else I can do. There's no more simplifying because I don't have like terms. So this is big. This is a huge idea in algebra that we can use this area model to explain how we multiply our polynomials. One question that you may have when you get to the homework is about those like terms. So remember that a like term has to have the same letters raised to the same power. So if I have something like 3xy plus 2x squared y, those are not like terms. That would be the simplest form. I can't put them together any farther because I treat those variables as a unit and they need to match each other in order to put them together. So with that little side note, the area model works when I have addition. If I have the addition of constants or if I have the addition of my expressions here. Does it work with subtraction? Yes, it does, but let's figure out how. So again, we're going to go back to our elementary skills here, and we're going to think about 81 times 19. So 81, I'm going to decompose into 80 plus 1. But 19, I could decompose it into 10 plus 9, but I could also represent this as 20 minus 1. You should agree with me that 20 minus 1 is the same thing as representing it as 19. And so what we're going to do when we see subtraction with our area model or with our polynomials in general is we want to think about it as really being addition. So I have 80 plus 1 and I have 20 plus a negative 1. We know that mathematically it's equivalent to say plus a negative as it is to say subtraction. Those two ideas are the same. So I'll rewrite it in my area model format, 80 plus 1 and 20 plus a negative 1. When I build my box, I'm going to put each piece where it belongs, and again I'm going to fill in the area of each separate piece to find my total area. 80 times 20 is 1600. 20 times 1 is 20. 80 times a negative 1 is a negative 80. And 1 times a negative 1 is a negative 1. So I'm going to rewrite this out again, and I have 1600 plus 20 plus a negative 80 or minus 80 plus a negative 1 or minus 1. And when I go through that process, I find out that my final answer is 1,539. And again, with two-digit multiplication, by the time you've reached my class, we would grab a calculator. But the area model works, and I wanted to show you that it works for addition or for subtraction. So for this next sample problem, it is out of your homework assignment. It's the second half of the first part of your homework here. We're going to do the same process though. This time I have 2 pieces for my first set and I have 3 pieces for the second. Like before, I'm going to take that subtraction and I'm going to turn it into plus a negative. So when I rewrite this here, I get 4y squared plus a negative 3. And in my vertical, I have 4y squared plus 7y plus 2. And I can build my box by extending those addition symbols. What you should notice is this time we're going to wind up with 6 pieces in our box because I have 2 in the first expression and 3 terms in the second. So now my steps follow the same. I get 4y squared times 4y squared, which using my wonderful exponent rules that I learned in the last chapter gives me 4y to the power of 4. 4y squared times a negative 3 is a negative 12y squared. 4y squared times 7y is 28y y to the power of 3. Well, that's a messy 8. Let's try that again. 28y cubed. 7y times a negative 3 is a negative 21y. 4y squared times 2, the area of this box is 8y squared. And the final area of the box is negative 2 times 3, which is negative 6. Like before, I'm going to rewrite it now, starting with my highest power exponent. So I see 4y to the power of 4. And then I see a 28y cubed plus 8y squared. We're going to jump below because my head's in the way. I have a minus 12y squared and a minus 6. So all of these pieces here, let's cut that off. When I'm looking at this, I see like terms. I have that 8y squared and a minus 12y squared. So my final answer, I'll rewrite it in green over here. I have actually I already used green. Let's rewrite it, we'll do red. We'll rewrite it in red. My final answer for this one here is going to be 4y to the 4th plus 28y cubed minus 4y squared minus 6. My final answer has each of those terms in it. And again, they're ordered. Oh, I forgot a piece. This is why we need to go through and cross them off as we write them. I had that negative 12y. I forgot my minus 21y. Let's erase my final answer here. We'll start over. When I get to this step here, I've crossed off most of the pieces. I have that minus 12y squared. Then I need to have minus 21y and then minus 6. Because my head's in the way, we will still rewrite it. Now that I have each piece written out, I can see that my final answer will be 4y to the power of 4 plus 28y cubed minus 4y squared, because I had a positive 8y squared and a negative 12y squared, minus 21y minus 6. I need to make sure that I have each piece in my final answer. So now that we've explored this idea of the area model, let's move on and we'll practice with foiling, or the distributive property. To FOIL tells me first, outside, inside, last. And so this here, what we're really doing is we're finding the same partial products that we did with the area model, but we're going to write it out a slightly different way. So what we'll do is we can leave it written out the way that it is now. To FOIL, I take first times first. So 4x times 6x is 24x squared. Then I'm going to do the outside pieces. So I have this outside times this outside here, and I get 4x times 3. Then I'm going to do my inside pieces. I have 1 times 6x, those pieces on the inside, and then I'll finish it out with my last terms here. 1 times 3 is 3. For my final answer, all I need to do is put together any like terms. So I see 24x squared plus 18x plus 3. So FOIL, using the letters first, outside, inside, last, only works when we have a binomial multiplied by a binomial. But the process of using the distributive property works even if I have more terms than that. If I have something like, we'll do an example over here, I have a plus b multiplied by c plus d plus e plus f. Same idea works. I take my first piece of my binomial or trinomial and I would apply it. I would multiply it by each piece separated by addition or subtraction in the second half. And then I do the same thing for the other side. I would multiply each piece across, and then I would need to combine any like terms that leaves me with. So the process works using the distributive property or an application of the distributive property, but the letters FOIL work when we're talking about a binomial multiplied by a binomial. One last practice problem here. The FOIL method or distributive property also works when I have subtraction, but again, I want to keep track of where my negatives are attached, so I want to turn this into plus a negative and plus, ooh, those are really messy plus signs. Let's try again. Ooh, I have a laser pointer. That's cool. All right, we're going to turn this into plus a negative and plus a negative. So I have 2x plus a negative 1 multiplied by the quantity 7x plus a negative 3. So first, 2x times 7x gives me 14x squared. Outside, 2x times a negative 3 gives me a negative 6x. Inside, I have negative 1 times 7x, which is negative 7x. And my last, my negative 1 times a negative 3, which gives me a positive 3. When I combine those like terms here, I see my final answer of 14x squared minus 13x, or plus a negative 13x, plus 3. It works with addition, it works with subtraction. I think it's easiest to keep track of where those negatives are attached if you remember that process, that subtraction is really adding negative numbers. This last one here, I'm not going to solve the whole problem for you, but number 6 on the worksheet is challenging. A contractor is building a deck around a pool. See image. He doesn't know what the deck size will be yet, so he calls it X. And what I can see from the picture then is that the edge of the deck is the same width all the way around the pool. I want to write a simplified expression for the area of the deck. So what we need to do is, I see that I have this deck with a pool in the middle, and I only want to know the area of this stuff that I'm coloring in yellow, which is really hard to see. Color of it in green. Just the outside, like the picture frame part of the deck. So what I need to do is I need to find the area of the whole thing, that black rectangle. Area of whole thing. And from that, I want to subtract the area of the pool. So when you're doing this, you're going to wind up with some complicated expressions. You need to figure out how you can multiply polynomials, and you need to figure out how you can add or subtract your polynomials here. This one is tricky. It may take you more space than what you have. If you need more space, you can flip it over and do it on the back of your worksheet, but make sure that when you submit your image to Teams that I can see all of your work, all of your steps to solve this problem here. On to the homework now. So you have 2 homework tasks attached to this lesson, so you should be working on it today and tomorrow. You have 2 days in the calendar to work on this. The first one, or one of them, you can choose to do them in either order. There's one assignment from the textbook where you're going to do page 474, numbers 1 through 15, and page 483, numbers 1 through 11, 33, and 34. The other half of this homework task is a worksheet. So the worksheet is posted on Teams. If you were in the building today, you have a copy of it. If you're in the building tomorrow, I have copies for you, or you can print it out at home. So both of those tasks are due by the end of the day tomorrow. Check Teams for due dates. The other thing is, if you are struggling with this head to delta math, this 4th skill on that assignment matches up with the skills you should have learned today. Thanks for working hard, ladies and gentlemen.